For the next two properties, let's consider the motion of a mass spring again. As you can see on the diagram that we referred to previously, the mass m is at its resting position O, because the net force acting on the mass is 0. If we pull the mass through a distance x up to the extreme position A and then release it, due to the restoring force of the spring, the mass moves back to the mean position O. The magnitude of the restoring force decreases with the distance from the mean position and becomes 0 at O. However, the mass gains speed as it moves towards the mean position and becomes maximum at O. Due to inertia, the mass does not stop at O but continues its motion and reaches the extreme position B. As the mass moves from O to B, the restoring force that is directed towards the mean position increases in strength, and therefore the speed of the mass decreases as it moves towards the extreme position and becomes 0 at extreme position B. Ultimately, the mass returns to the mean position O due to the restoring force. This process is repeated and the mass continues to oscillate about the mean position O. Here, the next two characteristic features of simple harmonic motion are found in this mass spring system. And they are, firstly, the body is vibrating about the same fixed point O. And secondly, the velocity of the body is maximum at the mean position O and 0 at the extreme positions A and B. So, the mass spring system satisfies all the features of simple harmonic motion. Hence, this motion is proved to be a simple harmonic motion. The time period t of the simple harmonic motion of a mass m attached to a spring is given by the following equation. T is equals to 2 multiplied by pi multiplied by whole under root m upon k. Now, I want to share an amazing fact with you guys. The human eardrum can make vibrations up to 20,000 times in a second. Isn't that amazing?